Have you ever really thought about what happens the second you pull the plug on a sink or flush a toilet? It's just gone. But where it goes is part of this incredible, completely invisible engineering marvel that's running behind our walls and under our streets 24/7. So today, we're going to follow that journey right from the very beginning.
You've probably walked past a little plaque like this 1,000 times and never really noticed it, but it's actually a huge clue. It's this direct, stark reminder that what goes down our drains doesn't just vanish into thin air. It has a destination, and that destination connects our homes, our lives, directly to the environment. In this case, right into a river.
Okay, so we know where the journey ends. But that's the final chapter of a really long and, you'd be surprised, a very complex story. So the real question is, what's happening in that hidden world between your sink and that river? Well, that's exactly what we're about to dive into. So let's start right at the source, the moment that water leaves your faucet and swirls down the drain. It seems like the simplest thing in the world, right? But that single act kicks off a process that engineers and architects have been perfecting for centuries. And this quote from Edward Allen just perfectly captures the central irony of our whole system. Think about it. We go to all this trouble and expense to create this pristine, high-quality, drinkable water, and then we immediately use it for, well, a pretty low-grade purpose, just to carry away our waste. It's amazingly convenient, for sure, but it instantly creates this massive disposal problem. All right, so now that perfectly good water is sewage. So what's next? Well, it enters what you could call a hidden gauntlet right there inside your walls. And this isn't just a bunch of random pipes. Oh no. It's a really sophisticated system that's designed to obey a few very simple but totally unchangeable laws of physics. What I love about this is how simple these rules are, yet they control everything about how our buildings are designed. The pipe's got to be wide enough, at least 4 inches, so things don't get stuck. They have to slope downhill constantly, and it's a fine line. If it's too steep, the water rushes past the solids, too shallow, and nothing moves. Gravity is the only thing pushing it all along. And maybe most importantly, the entire system has to be able to breathe. So the first line of defense in this whole setup is a really simple but brilliant invention, the trap. You've got one under every single sink in your house. That little U-shaped bend is designed to hold a small plug of water, and that water creates a physical seal. It's the only thing blocking nasty and actually dangerous gases from the sewer from bubbling back up into your home. But here's the catch. That simple little trap has a major weakness. When a big rush of water, say from a flushing toilet, goes down the main pipe, it can create this powerful vacuum behind it. And that suction is strong enough to literally slurp the protective water right out of the trap, breaking that seal and leaving your home totally defenseless. So how do you fix that? With another beautifully elegant piece of engineering, the vent. A vent pipe connects to the drain right after the trap, and it runs all the way up through the roof of your house. So when that vacuum starts to form, the vent just lets in a gulp of fresh air from the outside, which breaks the siphon and keeps that little plug of water safely in place. It's literally a lung for your plumbing. And here's where all that theory smacks into reality. Older buildings often used these super durable cast iron pipes. The problem is, their inside surface is kind of rough. So when you pair that with modern low-flush toilets that use way less water, you get more clogs. It's a great reminder that this whole system is interconnected. You change one part, and it can affect everything else down the line. Okay, so the waste has made it through the plumbing gauntlet. It's officially out of the building. But now what? Where is it all headed? Now we get to zoom out and look at the massive infrastructure that handles all this stuff for an entire community. You know, you might think this is a modern problem, but it's really not. Humans have been trying to figure out what to do with waste for literally thousands of years. From these incredibly advanced covered drains in ancient Mohenjo-Daro to Rome's famous Cloaca Maximus, and get this, parts of it are still in use today, all the way to the sewer systems we built in the 19th century that are basically the ancestors of what we use now. But for all that ancient history, the solution we have now feels pretty universal to a lot of us. The thing is, it's actually a huge privilege. This number, from a UN report back in 2006, is kind of staggering. It's a powerful reality check that, even in the pretty recent past, billions of people were living without the safety and sanitation that modern plumbing provides. So for those of us who do have it, the waste leaving our homes typically takes one of two main paths.
If you're in a city, it's heading into a municipal sewer system, this massive underground web of pipes that funnels everything to a huge central treatment plant. But if you're in a more rural area, there's a good chance you're one of the 20% of U.S. homes that uses a septic system, which is like a personal on-site treatment plant buried right in your own yard.
So whether it's going to a sewer or a septic tank, we live in this flush and forget world. And man, it is convenient. But that convenience comes with a pretty big environmental price tag. The very thing that makes these systems so good at getting rid of waste has accidentally created a whole new set of problems, mainly by breaking a really important natural cycle. Here's the problem in a nutshell. We grow food on farms, which pulls nutrients out of the soil. We then ship that food to cities, we eat it, and then we flush the waste, which is full of those same nutrients, away. But instead of putting those nutrients back on the farmland where they belong, we just dump them into our rivers and oceans. So we end up with two big problems. Our farmland gets starved for nutrients, so we need artificial fertilizers, and our waterways get choked with too many nutrients, causing these huge destructive algae blooms.
So that all sounds a little bleak, doesn't it? But this is where the story gets really interesting and, frankly, really hopeful. The most exciting new ideas are all about completely rethinking this process. Instead of seeing waste as this terrible problem we have to get rid of, innovators are starting to see it as a valuable resource we can actually use. A huge part of this shift is just getting smarter about water itself. I mean, not all water is created equal, right? You've got your high-grade potable water, the stuff you can drink. Then there's gray water from your shower or your laundry, which is pretty clean. And then there's black water, which has the toilet waste. So why on earth are we using pristine, drinkable water to flush a toilet when slightly used gray water would work just fine? And that's exactly what gray water recycling is all about. The logic is so simple. You just collect the water from, say, your shower. You run it through a basic on-site treatment system, and then you use that cleaned up, non-drinkable water for things like flushing toilets or watering your garden. It's a super direct way to cut down on how much fresh, potable water we need to produce. And we can take it even further by basically copying what nature already does so well. Things like constructed wetlands are a perfect example. You can actually build these small, contained ecosystems that use plants and microbes to naturally purify wastewater. You're literally turning a disposal problem into a thriving little habitat. How cool is that? And the cool ideas just keep coming. People are developing all sorts of amazing things, from indoor greenhouses that use snails and fish to clean water, to these super efficient little mini sewage plants, all the way up to huge lagoons that treat waste using just the sun and wind. It's all about finding ways to work with nature instead of fighting against it. And that really brings us to the final big idea here. This whole unseen journey of our waste, it's a story of amazing human ingenuity, for sure, but also of some pretty big unintended consequences. The next chapter really depends on all of us making a mental shift to stop seeing waste as the end of the line and start seeing it as the beginning of a whole new cycle. So what if our biggest sanitation problem could actually become one of our most valuable resources?